Hey guys, welcome to the OneClass channel. My name is Sydney and I'm currently a third year engineering student. Today we're going to be going over some commonly asked math questions at both the high school and university level. If you need any additional homework help or tutoring, please look at the links in the description below. And let's get started. Okay, so our first question for today is asking, how do you evaluate ln of 1 over e as in like exponential function? So if we want to evaluate this, we have ln of 1 over e. We can start by applying the property of the exponent. So property of the exponent. So in this case, because we have 1 over e, we can write 1 over e as e to the minus 1 instead. Because, let me write down the full law first. So this property, if we have just an arbitrary number as a and an arbitrary exponent as b, when you move this to the numerator, then it will become a to the minus b. So yeah, like I was saying before, if we go back to the ln of 1 over e, we can write this now as ln of e to the minus 1, since this is just a 1 in the exponent in the denominator, right? Okay, so now that we have this, we can apply a ln law. So this ln law states that the ln of a with an exponent b, if you have the ln of something with an exponent, you can carry that exponent out and place it out in front before the ln expression, and just take the ln of a. Okay? So let's apply that here in this case. So going back, ln 1 over e, or here, e to the minus 1. Because we have minus 1 as the exponent, we can bring that out front. So we have minus 1 times ln of just e now. Okay? And we also know that ln, oops, that was the wrong one. There we go. Ln of e, well, basically the ln is the same thing as, we know, it's log base e, right? So if you're taking log base e and you're taking the log base e of e, they essentially cancel out, so you get 1. Okay, so yep, ln of e is equivalent, or the ln function is equivalent to the log function with the base of e. Okay, so we know that ln e is 1, so that means we can turn that whole term to 1. So basically what I'm saying here is that ln of e to the minus 1 is equal to minus 1 times 1, or just minus 1. So let's write this in the original form we had it in. So we have ln of 1 over e, and that is equal to minus 1. Okay, so that's the answer for this question. And as we can see in the solution, we also get -1. Okay, correct solution. Oops, perhaps. Correct. Solution. All right, and we're good to move on to the next question. All right, oops. Here we go, question number 2. So this question is asking, what is the multiplicative inverse? Okay, so another way that we can describe the multiplicative inverse, let me write that down. Multiplicative inverse, that's equivalent, or it's also called the reciprocal. Okay, so you might have heard it called the reciprocal instead. So basically what that is the product of a number and its, I'm going to write reciprocal, it's easier to write. So the product of a number and its reciprocal is always equal to 1. Okay, so if we have a number a and we multiply it by its reciprocal, oops, a, so reciprocal is you're flipping the numerator and denominator. So, you know, every integer is over 1, but you just obviously don't write the over 1 or the 1 in the denominator. You only write what's in the numerator. So here we have integer, and here we have its reciprocal, and this is always equal to 1 because essentially you can imagine it as canceling each other out, right? And you're left with, well, if you have 1 in the denominator here, you're left with 1 over 1, or just 1, right? So the product of a number and its reciprocal is always equal to 1. So let's look at an example here. So if we have an example asking us what is, this is an example here. So what is the multiplicative inverse? The multiplicative inverse of 1/4, or 1 over 4. Okay, that's the question. There we go. So if we're applying what I was talking about up here, I kind of messed it up a little bit with all this extra stuff. But okay, so if we have our 1 over 4, we have, well, we don't know what the multiplicative inverse is, or the reciprocal is, so I'm going to leave that as x, but we have 1 over 4 times, well, 1 over 4, we'll leave it as y, or sorry, as a instead of x, because we have the multiplication sign. I don't want you to get confused. So we have 1 over 4 times a is equal to 1, because we know that the regular integer and the multiplicative inverse, when they're multiplied, the product is always 1. So now we have to find what a is, or the multiplicative inverse. So all we have to do is multiply both sides by 4. So if we do that, we have this side times 4 and the right side times 4. have distributing it into the bracket, we have, well, actually, I don't know why. This is, remember, a multiplication, so distribute it once into the bracket. Sorry about that. We just get 1 over 1 on this side, right? Or sorry, 4 over 4, which is just 1 on this side. I'll write out the whole thing. We get 4. Like I said, 4 over 4 is 1. So we get A is equal to 4. And if we write it in the full form up here, we have 1 over 4 times 4 is equal to 1. Okay, and we know that that makes sense. So this is our integer from the question. And this is the reciprocal. I'm going to call it reciprocal or multiplicative inverse. Am I spelling that right? I think so. Maybe with an O. Anyways, I think you get the idea. Yep, so we always get 1, so we know that that is correct. All right, and from there we're good to go on to the next question. So therefore, the multiplicative inverse of 1/4 is 4. So correct decision. All right, and next question. All right, so question number 3. We're asked, what is the order of quadrants in a graph? Okay, so first, let's draw this graph. So normally, the vertical axis will have y to minus y. Horizontal axis will have x to minus x, right? And so when we go through a graph like this, we have 4 different quadrants, and we usually start from, so this position here is usually 0, and then we move counterclockwise around the graph, so that we have pi over 2, pi, and 3 pi over 2, and 2 pi, or sometimes that's in radians. We can also think of this in degrees, obviously, so we have 0 degrees here, 90 degrees, 180 degrees, don't have anywhere to write this, 270 degrees, or 360 degrees. Okay, so yeah, that tells you go around counterclockwise in this circle. So that's how we label the quadrants. Then we label them starting in this first quadrant, right? You go through the first quadrant. So this is Q1. We usually use Roman numerals. Then we have the second quadrant. So this is Q2. Go through the third quadrant, Q3, and finally the fourth quadrant here, we have Q4. So that's Roman numerals for 4. I wrote 2 instead of 2 in Roman numerals, but here we go. Okay, and so basically, I guess the last thing that we have to label here, that this example labeled is when you're in a quadrant, you're able to tell automatically what sign x and y are in the quadrant. So we're on the positive half of the x-axis, and we're also in the positive half of the y-axis. So in the first quadrant, we have positive x and positive y. In the second quadrant, we're still in the positive half of the y-axis, but now we're in the negative half of the x-axis. So we have negative x and positive y, as I said. The third quadrant, we have both negative x and negative y. And in the fourth quadrant, we have positive x and negative y. Okay? So basically answering the original question, what is the order of quadrants in a graph? Well, if we move from counterclockwise around the plot, around the graph from 0, we get quadrant 1 here, quadrant 2, quadrant 3, and quadrant 4. Okay? Don't need those. And I think that's everything. Let's read through the solution here. So the Cartesian plane is a two-dimensional graph that contains all the negative and positive values of x and y. So based on these values, the Cartesian plane is divided into 4 different sections, called quadrants, and they are bounded by the x and y axes. So the first quadrant is the upper right corner of the graph, as we said, this quadrant here. And it's basically just talking about the positive and negative versions of x and y, which we've already talked about, so you can move on from that. Yes, and they are labeled from counterclockwise, or in a counterclockwise manner, so around the circle. All right, correct solution. And we're good for that question. Okay, question number 4. So question number 4 asks us, what is the square root of 1/2? Okay, so basically what it's asking is, what is the square root of 1/2? This fraction 1/2, right? Okay, let's start by using the rule. There is a rule for radicals. So I'm going to write this, I'm just writing it in green so you can see that it's the rule. So if we have a fraction of a over b with a square root, you can kind of imagine it as, instead of a square root, as an exponent, if this is easier to think of, because then you can think of distributing the exponent to each term within the bracket, so that it's a to 1/2 over b to 1/2. Or you can also think of it just going from this step straight to this step. Instead of a divided by b all within the square root, you have square root of a over square root of b. Okay, so that's the rule. So let's apply it to our square root of 1/2, okay? So if we have square root of 1/2, we have square root of 1 over the square root of 2. Now we know that square root of 1 is just 1, because 1 to any exponent is always just 1. And then, so we have 1 over square root of 2. Oops. Square root of 2. And now what we're going to do is something called rationalizing. Rationalize. And that is where we are multiplying this by we rationalize when we have a radical or a square root, I guess, on the number in the denominator. We want to get rid of the radical in the denominator, okay? We prefer to have them in the numerator when possible. So what we're going to do is rationalize, and that is multiplying the our original sort of term here by the radical in the denominator, found in the denominator. In this case, it's the square root of 2. So when we multiply by this, I guess, rationalizing term, you can see that essentially this rationalizing term is equal to 1. So that's why we're allowed to multiply our term by this factor, because it is equal to 1. So technically, multiplying by 1 won't change the grand scheme of things, I guess, or the overall equation. It will just rationalize the factor we're looking at, okay? I guess a long-winded explanation, but so to multiply, we get square root of 2 on the top, and in the bottom, we get square root of 2 times square root of 2. Or you can think of this in a couple of different ways. You can think of it as, let's write it like this. You can think of it as 2 times, or 2 to the 1/2 times 2 to the 1/2. And you can add the exponents here. So we, in the denominator, get 2 to the 1, because we're adding 1/2 plus 1/2, right? So you get 1. Or you can also think of it like this in the denominator. You can think of it as squaring the 2 or squaring the square root. So when you're multiplying these two here, you can think of it in either way, all right? But in the end, you get the same thing. You get the square root of 2 in the numerator divided by 2 in the denominator. And I mean, it might seem a little bit silly to be going from this term to this term, but essentially what we're doing is we're getting it to, now this is what's called the exact form. And it's the preferred form because it has the radical in the numerator, right? And that is, yeah, what we prefer. Okay, so now that we are here, this can be your final answer. So the square root of 1/2 is the square root of 2 over 2. Or if you want to plug that into your calculator, then you get like an estimated value. I say estimated because there's following decimals, but this is the evaluated answer, okay? Approximate, that's what the squiggly lines mean, the approximated answer. And that is everything for this problem, okay? So we get the same thing in the solution. So we can say correct solution, oops, and move on to the next question. All right, question number 5. So this question asks, what is the area of a trapezoid with bases 2 feet and 3 feet with a height of 1/4 foot? Okay, so let's draw this first. So trapezoid looks like this, where we have 2 parallel lines. Well, actually, I made it a little bit more even than it should be. We have 2 parallel lines, and I mean, I guess these 2 side lengths don't necessarily matter if the angles are the same or not. But basically, we have 2 parallel lines, one on the top, one on the bottom, and they're connected by 2 lines that are not parallel, so I don't need to draw those arrows. Okay, so in this question, they tell us that the bases, the first base is 2 feet, the second base is 3 feet, and the height here is equal to a quarter foot. There we go. Alright, so we have an equation for the area of a trapezoid. And that is equal to 1/2 times the base, the first base, plus the second base times h. Okay? So all we have to do here is plug in the numbers that we're given. So we have 1/2. So the first base we are given as 2 feet. The second base we are given as 3 feet. And the height is given as a quarter foot. Okay? So let's do this. 2 plus 3 is 5 feet. We have times 1/4 foot. And so multiplying 5 feet times a quarter foot, we get 5/4 feet squared. And then just multiplying by 1/2. Multiplying by 1/2, so in the denominator of this fraction, we have 5/8 feet squared as the total area, okay? So this is our final answer for the area of the trapezoid with a base of 2 feet, the second base of 3 feet, and the height of a quarter foot. And remember, it's feet squared for area, or the distance measurement is squared. All right, let's look at the solution. We have 5/8 feet, or 5/8. Not used to working in feet, I guess. So, correct solution. Okay, question number 6. So this question is asking us how to add with exponents. Okay, so to add or subtract numbers with exponents, we need both of the variables as well as both of the exponents to be the same. So when both of the variables and exponents are the same, these are known as like terms. So when the terms are alike, then we can apply a subtraction or addition to them, but otherwise we cannot add them or subtract them, okay? So let's look at a couple of examples. So example number 1, we have 3y to the 4 plus 25y to the 4, okay? So looking at these variables, we have y and y, so we have the same variable, right? And we see that both variables have the same exponent. Same exponent. So that just means the same value for the exponent, okay? So since we have the same exponent and the same variable, we can say that they are like terms. Therefore, we can add them. So let's just add the coefficients in front of these variables. So we have 3 plus 25, and then leave the exponent and variable the same. And we get 28y to the 4. So yes, as you can see, when they have the same exponent, same variable, they are like terms, and therefore you can add. But let's look at a different example now. So second example, if we have 7x squared plus 8y squared, now we're looking, we have the same exponent again. Which is a 2. Same exponent. But we notice that one is x and one is y, so we have different variables. And when you have unlike terms, or in this case we have two different variables, we can't add. So when we can't add, we'll just leave them the same. So it remains 7x squared plus 8y squared. Let's look at a third example. So example number 3. If we are given 4y cubed plus 4y squared, now we see that the variables are now the same. Variables are the same. But however, the exponents are different. Exponents are different. So since the exponents are different, once again, we can't add them. We'll just have to leave it as is. So we still have 4y cubed plus 4y squared. Okay, so just to review, in this first example, when the exponents were the same and the variables were the same, then we were able to add the coefficients to the variables in order to get our answer. Okay. Let's go down. Okay, and they go through the same examples. So correct solution. And we can move on to the next question. Question number 7. So this question asks how to convert. So we have 15 US pints. We want to convert this to gallons. Okay, so we have the conversion factor. And this conversion factor tells us that 1 gallon is equal to 8 pints. Okay? So when we start with 15 pints, in order to convert it to gallons, multiply it by this term. So we have 1 gallon for every 8 pints. And that's how I remember what to multiply it by. You want to put in the denominator the unit so that it essentially cancels out with the unit that is in the given term, okay? And in this case, we are left with 15 over 8, and since pints, the unit pints, it has been canceled out. This is in gallons now, and now we just have 15 over 8 gallons. And if you evaluate that with your calculator, you get 1.875 gallons. And that is your final answer. So 15 pints gives you 1.875 gallons after converting. All right, looking at the solution, we have the correct solution. On to our final question for today. We have question number 8. And this question asks, what is a multiple of 4? So we can easily come up with this little tiny formula that a multiple of 4 is equal to 4 times n, where n is an integer, okay? So any integer times 4 is called a multiple of 4, okay? So we can look at some examples. If we know 4 times an integer is a multiple, so we can use any integers we want, from basically 1 to infinity. So starting with 1, 1 times 4 is just 4. We have 4 times 2 is 8. 4 times 5 is equal to 20. 4 times 10 is equal to 40. And of course, you can go on with the unlimited numbers. A limited number of integers. And all of these answers, when you multiply 4 by an integer, the answers are all considered as multiples of 4. Okay? So that is what a multiple of 4 is. Alright, the solution. And in this example, they give 4 times 2 is 8, 4 times 3 is 12, and then 4 times 4 is 16, and 8, 12, and 16 are multiples of 4. Alright, that solution is correct. Great. So that's all we're going to be covering today. If you found any of this helpful, please leave a like, and when you want to be notified of when we do another Q&A like this, hit the subscribe button and the notification bell to be notified. If you want to submit any of your own questions, you can look at the links in the description below and see where to submit those. So thank you for watching tonight. Have a good night.